Hi guys, so this video today is all about how to construct ionic equations. This is something that lots of people struggle with, so we're going to go through it nice and slowly, step by step. So firstly, why do we bother writing ionic equations? Let's look at an example. Sodium chloride is an ionic substance. That means that it's a metal and a non-metal. It's arranged in a lattice, so you've got these positive, negative ions arranged nicely, just like this. But wait, I've written a little AQ next to my sodium chloride, and that means that the sodium chloride is in solution. And in solution, ionic compounds do not maintain that lattice. Instead, they are broken up into individual ions and they're free to move throughout the solution. That's what lets it conduct electricity. So if I write NaCl aqueous, that kind of means that it's all attached together, which doesn't really explain what's really happening. So instead, in an ionic equation, we write the ions separately. So you've got NaCl turning into Na plus aqueous and Cl minus aqueous, which really shows what's happening in the solution. Let's try our first example. This is the test for chloride ions, if you've studied that already. So we've got silver nitrate aqueous reacting with sodium chloride aqueous, making silver chloride, which is a solid, a precipitate, a white precipitate in this case, and sodium nitrate, which is also aqueous. So if we look at the silver nitrate first, we know that that's an ionic compound. It's made up of a metal and a polyatomic ion. So we can split that into its ionic pieces. So you've got your Ag plus ion and your NO3 minus ion. That's what's really in solution, so split those up. The NaCl is also aqueous, it's in solution. So really those ions are split up. So we split them into Na plus and Cl minus, both aqueous. On the other side, we look at AgCl, which is also ionic. But what's different about this is that it's actually a solid. So if it's a solid, that means that it really is that lattice. It's laid out, positive, negative, big 3D arrangement. So AgCl together is okay for this because it's not split up. It's not aqueous. So I'm going to keep that as AgCl solid. The last one, the silver nitrate, the NaNO3, is also aqueous and is ionic. So that means that I also need to split those up into their constituent ions. So now this looks way more complicated than it was to start with. But if I look a little bit more closely, what you'll see is that actually some of the ions come up on both sides of the equation. The nitrate ion is on the left and on the right. And actually, if this happens, it means that I can cancel them out. If they're there at the beginning and they're there at the end, then nothing really happens to them. We call them spectator ions. They spectate, they don't really do anything. The Na plus is the same. They exist on both sides, so I can cancel them out. So now, if I rewrite the equation, Ag plus aqueous plus the Cl minus aqueous gives AgCl solid. I can see that clearly this is way simpler than the equation that I started with because I've taken out all of those ions that were doing nothing. Right, so one more example and then I'm going to leave you to have a go at one yourself. So this is neutralization this time, hydrochloric acid plus sodium hydroxide to give you the salt and water. All of the things that are aqueous, that are in solution, can all be split up into their constituent ions. So what we've got is we've got HCl being split up into H plus and Cl minus. The sodium hydroxide can be split into Na plus and OH minus. The NaCl can be split up into Na plus, Cl minus, all good so far. The water, whoa, the water is covalent. So it's covalent, so there's no ions. It's also a liquid, which tells you that it's not dissolved in anything, so therefore we can't split that up. You can't split up something that's covalent, there's no ions. So we leave the water as H2O liquid. If we look at these and cancel out anything that's on either side, you've got the Na plus on both sides and the Cl minus on both sides, and now all I've got is this general equation for neutralization that you might have seen before, which is H plus and OH minus gives you H2O. This is the last example of the video. Have a go at pausing it here, seeing if you can solve it yourself before I go through it in a couple of minutes. Pause it, have a go. So, let's see what you came up with. All of the things that are aqueous are all ionic, so I can split them all up into their constituent ions. The only thing I can't split up is the barium sulfate, which is a solid. So let's split all of these up. The only thing you might have got confused with was the chloride of the barium. So the chloride, you've got two Cl minuses. It's not Cl2 minus or anything weird like that. You've got two Cl minuses existing there on both sides. If you cancel everything out, you'll get the sulfate ion plus the barium to give you barium sulfate. And this is the test for sulfate ions that is also in your syllabus. Practice these, get lots of them, have a go back to the one at the start of this video, see if you can do that on your own. Otherwise, practice. Good luck.